All right, there was one time I was throwing a frisbee with my buddy, and we were in kind of a wooded area, which was the first mistake. But I go to throw the frisbee to my buddy, and he never caught it, and in fact, it never came down from anywhere. Symmetry. All right. All right. Hello, algebra. Sorry for that horrible dad joke. But as promised, we've got another video in which case we're going to examine the graph of an equation. In particular, we're going to find the intercepts and try to determine if there are any symmetries that the graph has. So we'll do this with example part B. Let's see if it's got any intercepts. Okay, so you can either have x-intercepts and or y-intercepts. And we want to look for the spots on the x-axis where the graph is crossing it, if there are any. And there appear to be 3 spots where the graph is crossing the x-axis. And based on the tick marks and their scaling, it appears that we have an x-intercept at -4, 0, 0, 0, and +4, 0. Those would be the x-intercepts. This graph does cross the y-axis as well, and it crosses at 0, 0, which happens to be one of our x-intercepts, and that can happen. So those would be the intercepts of the graph. Let's move on to determine what type of symmetry it has, if any. Alright, we'll start by seeing if the graph has x-axis symmetry. And what we'll do is we'll reflect the different parts of the graph across the x-axis and see if it would generate the original version of the graph. And if we maybe examine the part of the graph that's in quadrant 1, if we reflect that across the x-axis, that hill turns into a little valley, which would not line up with any part of the original version of the graph other than the intercepts. So my point with this is that you sometimes can get away with, eliminating these symmetries, right off the bat by just using maybe one piece instead of the entire graph. This would be enough to conclude that it does not have x-axis symmetry. But just in case you're wondering what the rest of the graph would look like after reflecting across the x-axis, you'd have one end pointing up in quadrant 1. The valley in quadrant 3 will turn into a hill in quadrant 2. And that end that's pointing up in quadrant 3 will now point down in the one end that's pointing up in quadrant 2 will now point down in quadrant 3. So this does not match the original. I'm just going to put no x-axis symmetry. Now for y-axis symmetry, our line of symmetry is going to be the y-axis. And if we reflect that piece in quadrant 1 from the original graph across the y-axis, we'll get a hill still, but it'll now be in quadrant 2. And based on our original version of the graph, we don't have a hill in quadrant 2 for that one to line up with, so we can conclude right from there that there's no y-axis symmetry. But just for sake of completion, I'll draw the rest of the graph upon reflecting them across the y-axis. And our final graph would not match with the original version of the graph, so we can conclude that there's no y-axis symmetry. Okay, well, let's examine whether or not it has origin symmetry. Remember, there are two reflections that you have to do. The first one is across the y-axis, and then after that is across the x-axis. So if we take that hill that's in quadrant 1, reflect it across the y-axis, as we saw in that last part, we get a hill in quadrant 2, but we're not finished. We now have to reflect this across the x-axis. So again, we do the y-axis, then we reflect across the x-axis, and our final resting spot for that hill that was in quadrant 1 is going to be in quadrant 3 as a valley. Now the rest of the graph, upon doing both reflections, be something similar to that. And all things considered, if we compare this with the original version of our graph, and if we were to do this with 100% accuracy, we would actually see that it lines up with the original version of the graph, which means that we have origin symmetry. Orange, you glad you know that now? Anyway, I do want to just make a little side note here that you can go through all three phases of reflections, or go through all three tests here, x-axis, y-axis, or origin symmetry, and still not wind up with the original version of the graph. That can happen, and if it does, then all you need to conclude is that there's no symmetry. Okay, so it would not have any of those three types of symmetries, particularly x-axis, y-axis, nor origin symmetry. And that's where the fun and excitement for this video will end. Thanks for grinding your way through it. Let me know if you have any questions. If not, then I'll see you in the next one. Thank you.